All right, so hopefully everybody had a chance to do this group work on your own, and you're just using this video to check your work or see what questions that you had that hopefully I can answer. So the group work, it says earlier in this unit, we put a lot of energy into modeling the cost of taking cab in Vegas. There is an initial charge of $5.10 plus $2.60 per mile. Is this an example of direct variation? No, it is not, because there's an initial charge of $5.10, and that's going to ruin it. So if I was to double 260 times 2, right, that would be $5.20, but you're not paying that for 2 miles. You're paying $10.30. So direct variation problems have to have an initial value of 0, so it's not. Do you think the amount of money that you would spend at a gas pump and the number of gasolines purchased would vary directly? Yes, because they're always going to start at $0. You get 0 gallons of gas, you pay $0. So yes, this is a direct variation. All right, number 3. Let's say you stop in a local gas station just to buy an energy drink. You don't pump any gas. How much would you pay for 0 gallons of gas? You wouldn't pay anything, right? You're not paying any money for gas. You're paying money for the energy drink, but the question says, how much would you pay for 0 gallons of gas? Nothing. Question 4. If 5 gallons of gas costs $11.10, how much would you pay if you double the amount purchased for 10 gallons? Well, 5 gallons, if I want to double that, right, I'm going to do double the $11.10. So $11.10 times 2. If you want 10 gallons of gas, you're going to pay $22.20. What if you wanted to get half of that and you only wanted 2.5 gallons? Well, then your cost is going to be cut in half. So $11.10 divided by 2 is equal to $5.55. Now, I just want to put a quick note here. I chose to divide by 2 because I know that half of something is the same thing as divide by 2. This is also the same as multiplying by a half. So multiplying by a half is the same as dividing by 2. I personally think dividing by 2 is easier, but you could also multiply that by a half or 0.5 and you would get the same answer. All right, so now let's take this into a more interesting question. How much would you expect to pay for 15.2 gallons of gasoline, right? Because you're not always getting a perfect amount of gasoline. So if you got 15.2 gallons of gas, how much would you pay? Well, this is not as straightforward because we're not just doubling it or tripling it or cutting it in half. So we got to figure out what we need to do. So it says here in question 6, in lesson 3.3, we learned that an equation stating 2 ratios are equal is called a proportion. So we are going to set up a proportion to figure out how much we're going to pay for 15.2 gallons of gas. So a proportion is when 2 ratios or rates are considered equal. So I know that 5 gallons costs $11.10. And I know we have 15.2 gallons. So see how gallons is in the numerator here? I had to put gallons in the numerator here. And I want to know X dollars. I just want to point out this would also work if you put dollars on top and gallons on the denominator. Okay, you could flip them as long as you flipped both of the rates. It does not matter. Now we're going to cross multiply. 5 times X is 5X. And then we have 15.2 times 1110. 15.2 times 1110. I multiplied, got 168.72, and then I divided by 5 to get X by itself, and you get 33.744. Well, that's not money. So money has 2 decimal places, which means it would cost $33.74. Okay, so just make sure you're answering the question. All right, so now let's see. How can we solve this gasoline problem using direct variation? Well, we know that the cost is going to be equal to the constant of variation times the number of gallons, right? Well, what's the constant of variation going to be? Okay, that's what we're going to have to figure out. So first, our equation is going to be cost is equal to some number, constant of variation, times G, which is our gallons of gas. So question 8, 5 gallons costs $11.10. So the cost is equal to some number times 5. Well, what is K going to be? Well, 1110 divided by 5 is going to be 222. What does this mean? Well, first, the constant of variation is 222, and that is also the price for 1 gallon of gas. So if 5 gallons is $11.10, 1 gallon of gas is $2.22. So the constant of variation is really the same thing as our unit rate or the slope, the price per one thing. okay? So now we can rewrite our variation equation so that the only numbers are C and G. Well, we know K is 222, so I just replace K with 222. Cost is equal to $2.22 times the number of gallons. What does the constant of variation you found describe about buying gas station? $2.22 is the cost per gallon. So how much would you pay for 15.2 gallons? Multiply 222 times 15.2 equals 33.74. All right, and then in this table, I did the same thing. I just multiplied, these are my number of gallons, so 222 times 3 gives you 666. 222 times 6 gives you 1332, and so on. All right, what would it cost you to put 11.55 gallons in your car? Well, I'm taking 11.55, multiplying it by $2.22, means it costs $25.64. Okay, now, if I spent $40, so $40, now we're looking at something else. Before, we kept replacing G in the equation, but $40 is now my cost. So cost, 40, is equal to $2.22 times the number of gallons. So to solve this, I have to divide both sides by 222, and 40 divided by 222 gives me 18.01. So they pretty much bought 18 gallons of gas. All right. This right here, it is just some notes on solving problems with direct variation. Read it. Let me know if you have any questions. All right. Now here's another problem. You get paid hourly at your job. Your total amount of money can vary directly with the number of hours you work. So if you worked 14 hours last week and made $163.80, so $163.80 is equal to K times 4. I want to find the constant of variation, right? We want to know, well, if they only work for 1 hour, how much would they make? So 163 divided by 0.80 divided by 4 is $11.70. So they earn $11.70 every hour. So I'm going to plug that in. The amount of money you make is equal to 11.7 times how many hours you work. Plug in 20, plug in 25, and you'll figure out the costs. All right. So how to solve direct variation equations in general? Well, we know y is equal to k times x, and k is our constant of variation. So if I want to solve for k, you just do y divided by x. And the ratio of y to x is constant. So no, slope is also y divided by x, right? So constant of variation and slope are the same exact thing. All right. So my mini-me is 5.82 inches tall. That handsome little devil. How tall am I in feet and inches? Well, we know, okay, it tells us in this paragraph above that the ratio of mini-me size to the real thing is 1:13. So we know our ratio 1:13, and the mini-me is 5.82, and I want to know how much is the real thing, so here's my proportion. 1/13 is equal to 5.82 over x. Solve it, we're going to cross multiply. 1 times x is 1x, 13 times 5.82, and you get 75.66, which is 6 foot 3 3/4 inches. Well, it says the actual mini-me was 32 inches tall. If we had made a bobblehead, made the same scale, how tall would it be? Well, 32 is now the actual, so I'm going to put 32 in the denominator, and we're trying to figure out what the little scale would be, and they're still going to cross multiply again, and you get about 2.46 inches, so we're just rounding to 2.5 inches tall. All right, the sales commission earned by a saleswoman varies directly with her gross sales. Her commission was $7,200 on 18,000. Or they're missing a zero here. 72,000 divided by 180,000 gives you 0.04. I'm just gonna make sure that I did that because it's missing a zero. 7,200 divided by, yep, is 0.04, which is 4%. So here's a commission rate of 4%. So commission is equal to 0.04 times her gross sales. So her gross sales times 4% is going to be her commission. And for 21 in this chart, I took her gross sales, multiplied all these numbers by 0.04, and that's where these numbers came from. Okay, question 22. It says, earlier we observed that the number of rubles goes up, so does the number of dollars. And we also saw that when you buy gas, the amount of gas you buy goes up, so does the cost. Is that always the case? If the constant of variation is negative, what effect would on Y? What would be the effect on Y if X increases? Explain. Okay, so just because when you bought more gas, the cost went up, right? That makes sense. You're buying something, but it's not always going to be that type of situation. Sometimes things might vary directly in the negative way. So if Y decreases, X is still going to increase, because we need one negative to make a negative. Okay. Example would be the value of something going down. All right. So everything's not always going to be a positive constant of variation. Some things will be a negative variation. All right. Last page. Do these illustrate direct variation? Number 23 and 25 do. Okay, because they both start at the origin. Anytime something starts at an origin, it's going to be a direct variation. 24 does not start at the origin. It starts up on the y-axis. So that is not a direct variation. All right, so let me know if you have any questions. Work on the homework. And remember, the homework is due on Monday morning at 9:30.